Okay, on problem number 1, it says we're going to take the limit as x approaches 2, 2x squared minus 6x plus 1. So to solve this problem, we just want to go ahead and use substitution. So substituting in this 2 into our equation, we're going to end up with 2 times 2 squared minus 6 times 2 plus 1. Now we need to go ahead and solve that. So we're going to take 2 squared, which is 4, and 2 times 4 is going to be 8. We got minus 6 times 2 is going to be 12. I'm going to add 1 to that. We've got 8 minus 12 is going to be negative 4 plus 1. And negative 4 plus 1 gives us our answer of negative 3. On this next problem, on number 2, it says it wants us to go ahead and it says if the limit as x approaches 3 of 3x minus 2 equals 7, says go ahead and use the epsilon delta definition to prove the limit. So our epsilon delta definition, we just need to remember that our epsilon delta definition is this definition right here, which is f of x minus my limit, and that's the absolute value of it, is less than epsilon. And then we also have to remember this other part, which is 0, is less than the absolute value of x minus c, which is less than delta. To remind ourselves, f of x is going to equal 3x minus 2. My c is right here, which is 3, and then my limit here is 7. So now we're just going to go ahead and substitute in all those numbers. So in place of my f of x, I'm going to put 3x minus 2. In place of my L, I put 7, and that's still less than epsilon. And then in my other side over here, I'm going to go ahead and substitute in 3 in place of my C. Now that I've done that, I'm just going to go ahead and work from one side to the other, step by step showing how those will equal each other. So solving this down, I'm going to take 3x minus 2 minus 7. So negative 2 and negative 7 is going to give me this 3x minus 9. Now I'm going to go ahead and factor out this 3. So when I factor out this 3, I get 3 times x minus the absolute value of x minus 3 is less than epsilon. And then I end up with dividing both sides by 3. I get x minus 3 is less than epsilon all over 3. Now that I've done that, it matches with this other side. So since it matches with this other side, I'm going to write it underneath this other side. So I'm going to scroll this down just a little bit here. And I'm going to go ahead and write this underneath here. And so this matches, and that's our entire goal, is to make sure that it matches. So once it matches, we can see that this delta is going to equal epsilon over 3. So therefore, I'm going to rewrite this as 0 is less than x minus 3. Now substituting in the epsilon over 3 in place of my delta, I get less than epsilon over 3. Now I just got to go ahead and work this back to the other side. So working it back to the other side, let me scroll this up just a little bit. Okay, now I've got 0 is less than the absolute value of x minus 3, which is less than epsilon over 3. Well, absolute value is always greater than 0, so I can go ahead and drop that. Okay, now I'm going to multiply both sides by 3. So multiplying both sides by 3, that cancels out. And now I'm left with 3 times the absolute value of x minus 3 is less than epsilon. Go and distribute this inside, so you get 3x minus 9 is less than epsilon. Now rewrite it, so it is 3x minus 2 minus 7 is less than epsilon, which just shows you that my f of x, which is 3x minus 2, my L, which is my 7, is less than epsilon. And now I've worked from one side to the other. I've shown that my x's equal my y's, and my y's equal my x's. Okay, number 3, it says, find the limit as x approaches 1 of f of x, if f of x equals, and then we've got a piecewise function, we've got x squared plus 4, if x doesn't equal 1, and 2 if x equals 1. So notice we have to remind ourselves that this means approaches. So since we're not actually getting there, so this is calculus, this is not algebra. Algebra we get there, calculus we approach. So that means we're going to substitute it into the top equation. So taking 1 and putting it into my top equation, I get 1 squared plus 4 and then 1 squared plus 4, solving that. It looks like the answer is 5. So 1 squared plus 4 is 5, and that's my answer when I substituted in this top equation. So on this next problem, it says that I have the limit as x approaches -1 of x squared plus 3x plus 2 over x squared plus 1. You're going to notice that the x squared plus 1 is in your denominator. And notice the x squared plus 1 doesn't produce any problems with as far as having our domain undefined. So since there is nothing that is stopping this from being a continuous function, because notice if I take x squared plus 1 and set equal to 0, we know that can't equal 0. So x squared cannot equal -1. And when I take the square root of that, notice I get those imaginaries. And so if that is plus minus I, that means that that's actually not, hasn't any problems with it. So we're just going to go ahead and substitute this in and find our answer, because there is no breaks in our graph. So substituting this in to find the answer, I'm going to go ahead and just take -1, substitute in for my x values, and then I just go ahead and solve this. Substituting that in, I got -1 squared is 1, 1 plus 1 is my denominator. Now, in my numerator, I got -1 squared is 1, and -1 times 3 is going to be -3, and I still have my plus 2. Now I just have to go ahead and simplify that down. So simplifying that down, I got -1 minus 3 plus 2, so -1 minus 3 is going to be -2, -2 plus 2 is 0. And then in my denominator, I have 1 plus 1, which is 2, and 0 divided by 2 is going to be 0. Okay, number 5 says I've got the limit as x approaches 2 of the square root of 4x squared plus 9. So I'm going to use substitution to solve this problem. So substituting in this 2 into my equation, I've got 2 squared. So now working that out, I got 4 times 2 squared, so that would be 16 plus 9, and 16 plus 9 is 25, and square root of 25 is 5. Now with any radical, I always like to double check by graphing it to see what the graph looks like, just to make sure that I haven't hit any areas of my graph that are the endpoints of my square root. And so I always double check with a graph. And so when I graph this equation, that's what it looks like. And it looks like there are no breaks or gaps or holes in it. So it looks like at this point, as I'm approaching this 2 is equal to my 5. Okay, number 6. It says I've got the limit as x approaches c of f of x equals -1/2. And the limit as x approaches c of g of x equals 2/3. So the limit as x approaches c of f of x minus g of x is what I'm looking for. And it just says that I just need to remember the limits follow the laws of algebra. So I can just go ahead and subtract them. So taking my 2 equations right here, so this one was equal to -1/2. This is equal to 2/3. So limits follow the laws of algebra, so I can actually just take -1/2, subtract 2/3, and find that answer. So finding that answer, I just need a common denominator. So my common denominator is 6. So I'm going to multiply this one by 3. And I need to multiply this other one by 2. Getting my common denominator, so I get -3/6 minus 4/6. I add or subtract my numerator. -3 minus 4 is going to be -7. I keep my same denominator, which is going to be 6. Okay, on this next problem, on number 7. Number 7 says I've got the limit as x approaches -2. And I've got x plus 2 over x cubed plus 8. I'm going to go ahead and substitute in this -2. And when I do that, I'm going to get negative 2 plus 2 for my numerator. I get negative 8 plus 8 for my denominator. That gives me 0 over 0. That's my indeterminate form. So that means that there's something that I can do to go ahead and find this answer. So you can either factor it, or you can actually just divide it out. So notice if you want to factor it, the pattern for factoring is I take the cube root of this first term right here. So I take the cube root of x, which is cube root of x cubed, and that's going to give me an x. And then I'm going to take the cube root of 8, and that gives me my 2. So now that I've factored out the x plus 2, this is a conjugate pattern. So my conjugate pattern, I just ask myself, what times x is going to give me that x cubed, that is x squared. And then I have to change this sign right here. That becomes negative. When I put these two together, that's 2x. And then I just ask myself, what times 4 is going to be 8. That's a pattern that you learn, and most of the time we don't really use that pattern. So the easiest way to do it is just go ahead and divide it. So taking my x plus 2 and dividing it into 2 by x cubed plus 8. So notice I fill in all those areas that are missing with the zeros. So I'm going to take x plus 2 into x cubed plus 0x squared plus 0x plus 8. So then I just ask myself what times x is going to give me x cubed. So that first term is x squared. And I multiply. And so multiplying this, so x squared times x can be x cubed. And then plus 2x squared, and then I subtract. And subtracting those, when I subtract those, so x cubed minus x cubed is 0, and 0 minus 2x squared is going to be negative 2x squared. I bring down my next term, which is 0x, and then I multiply. So what times x gives me negative 2x squared, so that's going to be a negative 2x. I multiply it on through, so that gives me negative 2x squared minus 4x, and I subtract again. So negative 2x squared minus 2x squared is 0. 0 minus a minus 4 is going to be a positive 4x plus 8. So now I go ahead and finish this off, just asking myself what times this x is going to give me that 4x. So that's going to be times 4. I multiplied, I get 4x plus 8. So bringing down my 4x plus 8 and subtracting them, that's going to give me a remainder of 0, and that tells me that I did it correctly. And there's my factor of it. So now notice this times this equals the x cubed plus 8. So I just go ahead and write that underneath here. And then I'm just going to go ahead and subtract those on out. Or sorry, cancel those out, so the x plus 2's cross out. And now I've got my equation of limit as x approaches negative 2 of 1 over x squared minus 2x plus 4. Now I can go ahead and substitute that in again, now that I've eliminated that problem. And I can find my answer. So here's my equation. The limit as x approaches negative 2. And substitute this in for my x values. So I get 1 over negative 2 squared minus 2 times negative 2 plus 4. Well, negative 2 squared is going to be 4. Negative 2 times negative 2 is also 4. Plus 4. And 4 plus 4 is going to be 12. So my answer is 1/12. Okay, on problem number 8, it says we have the limit as h approaches 0, the square root of x plus h minus the square root of x all over h. So first thing we're going to do is we're going to use substitution. So when we substitute this problem in, we're going to replace my h right here with 0. So when I do that, I'm going to get the square root of x minus the square root of x is 0. And that's 0 over 0. So that's my indeterminate form. So that indeterminate form tells me that I can go ahead and do something to go ahead and still find the answer. So what I'm going to do is I'm going to go ahead and rationalize my numerator. So to rationalize the numerator, I'm going to multiply both top and bottom by the conjugate, which is the square root of x plus h plus the square root of x, and the square root of x plus h plus the square root of x. So when I multiply this, I'm going to notice that when I multiply my firsts, so here's my firsts right here. So the square root of x plus h times the square root of x plus h, that's just going to give me x plus h. And since they're conjugates, Outside's inside is going to cross out, so I just have to multiply last. So I get square root of x times the square root of x, which is going to be negative x. And then here's my denominator. And remember we talked about this, you don't multiply it on through, you just go ahead and keep it as it is. So I've got h times the square root of x plus h plus the square root of x. Okay, now that I've done that, I'm going to go ahead and take this problem, and I'm going to go ahead and cross off my x's. So my x's cross off, and I'm just left with h up here. I have my h down there, so these are going to cross out. And when those cross out, I'm going to be left with 1 all the square root of x plus h plus the square root of x. So now I'm going to go ahead and take that problem and rewrite it. So when I rewrite it, this is going to be the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. So you're going to use substitution. So here I'm going to substitute in my 0. Substituting in my 0, I end up with 1 all over the square root of x plus 0 plus the square root of x. Square root of x plus 0, of course, just the square root of x. I add those together and I get 1 all over 2 square root of x. Okay, number 9. The problem says it wants me to find the limit. And then it says that I have this. X approaches 1 of x minus 1 over the absolute value of x minus 1. So notice when I do substitute in 1, I do get the form of 0 all over the absolute value of 0. This is not the indeterminate form. So what you're going to want to do is you're going to want to go ahead and graph this. So when I graph this problem, this is what my graph is going to look like. So put it into our calculator. Make sure you guys can put it in your calculator correctly. Just take a calculator and we'll slide it over here. So take your calculator, go to your graph. And we talked about this basic graph. And so we're going to go ahead and type this in here. So make sure you put parentheses around your numerator and denominator. So we've got x minus 1 in my numerator. Make sure you put parentheses around it. Then we're going to divide by, and then if you go to second, go to your catalog. There's your absolute value key in your catalog. Hit enter. I'll put your absolute value brackets in there. So now let's type in x minus 1. And then when we're done, we'll go ahead and hit zoom and zoom standard, change it back to 10 by 10 viewing window. And you can see that there's my graph, makes those jumps right there. So notice that as I'm approaching from both directions, so as I'm approaching from the right and also from the left, there's a big gap there. And so that's why this leads us to our answer of does not exist. Okay, number 10 says it wants me to find the limit as x approaches 5 of the cotangent of pi x all over 6. So I'm going to use substitution. I'm going to take my number 5 and substitute into my in place of my x, and I get the cotangent of 5 pi all over 6. So remember the cotangent is the cosine of pi over 6 all over the sine of 5 pi over 6. So this one you're going to have to get off your chart. So I know that my reference angles is just pi over 6. So looking at my chart, I know that the cosine of pi over 6 is going to be the square root of 3 over 2. The sine of pi over 6 is 1/2, and you just get that off your chart. And then you go to 5 pi over 6. So remember 5 pi over 6 is in the second quadrant. Cosine is negative in the second quadrant. And sine is positive. So you're going to flip and multiply, and you get negative square root of 3 as your answer. Okay, number 11, it says find the limit as x approaches 0 of x over the sine of 3x. So you're going to use substitution. So I'm going to go ahead and substitute in the 0 into my x values. And when I do that, I get 0 over the sine of 3 times 0. Well, the sine of 0 is going to be 0. And so I've got 0 over 0. So I'm going to use the squeeze theorem. The squeeze theorem says the limit as x approaches 0 of x over the sine of x is all going to equal 1. So substituting this in, go ahead and rewrite this. And when I go ahead and put the 3's in there, I'll get 1/3 times the limit as x approaches 0, 3x over the sine of 3x. So remember this is equal to 1, so that's 1/3 times 1. So my answer is going to be 1/3. Okay, on this next problem, we've got the limit as x approaches 2, and we're going to approach it from the right side of the square root of 2x minus 1. So the very first thing I want to do is just use substitution. So I'm going to use substitution. When I substitute that in there, I got 2 times 2, which is going to be 4, and 4 minus 1, which is going to be the square root of 3. Now that I've got my answer, remember when we talked about the square roots? They're root symbols, they're radicals. You always want to check to make sure they exist by graphing them. So there's 2 ways you can graph this. You can take your calculator, and you can just type in the square root of 2x minus 1. We're just doing this to make sure that our problem exists at that particular point. So the square root of 2x minus 1. So you can notice that here at 2, it looks like it's sitting about right there at about 1.73. So it looks like it does exist. So you always want to check your graph to make sure that it still exists right there. So that square root of 3 is 1.73. So whenever you're doing your roots, just check by graphing to make sure that you are hitting an area that is not where that square root graph is ending at. On this next one, on number 13, it says that I want to find the limit as x approaches -1. And it looks like I'm going to be approaching this from the left of 1 all over x plus 1. So I'm going to go ahead and substitute that number in. So when I substitute this in, my -1, I get, instead of my 1 up top, -1 plus 1 is going to be 0. I get 1 over 0, which is a constant over 0. So I know that it's either going to infinity, -infinity, or it still does not exist. So go ahead and graph this. So you put this in your calculator and graph it. Or you just graph this out by hand because this is a basic graph. So remember your asymptote is going to be at -1. So notice I put a dotted line here at -1. And this just follows my basic graph that we learned last year of my rational equation. So now I'm going to be approaching it from the left. So approaching it from the left, I just follow this down. So following that down, this is telling me that it looks like it is going to -infinity. So that would be my answer, would be -infinity. Okay, on number 14, it says it wants me to find the limit. And I'm going to go ahead and scroll on up to 14. So the limit as x approaches 3, of 3 all over x squared minus 6x plus 9. You're going to use substitution again. So as I'm substituting in my 3, so my 3 goes in plus my x squared, and my x next to my 6. Substituting that in, I got 3 squared, which is 9, minus 18 plus 9. So I got 9 minus 18 plus 9. That's going to give me the 3 over 0. So again, I've got a constant over 0. So I know that I'm going from either to infinity, -infinity, or it does not exist. So again, graph it and do this from a graphical standpoint. So when I graph this, you take your calculator, type that in there. So you go to your y equals, and type this in. So we've got 3, divide by, and then put parentheses around your x squared minus 6x plus 9. Get your graph key. And this is what your graph looks like. So your graph doesn't show on your calculator the asymptote, but you know that asymptote is happening at 3. And the reason why you know that asymptote is happening at 3 is because this is x minus 3 times x minus 3. In other words, this is x minus 3 squared. So that's where it's undefined at. So since it's undefined right there, I'm going to go ahead and put in my asymptote. So my asymptote is at 3. And since this is being squared, it means it's always positive. So they're both going to be on the positive side of it. And you can verify that with your graph. So now we're going to approach 3 from both sides. And now approaching 3 from both sides, it looks like this side is going to infinity, and this other side is going to infinity. So therefore my answer would be infinity. On this next problem, on number 15, it says I've got the limit as x approaches 0 of 3x plus 2 plus 1 over x squared. I'm going to rewrite these all out separately and separate them out across my addition signs. So I'm going to rewrite this as limit as x approaches 0 of 3x. Limit is x approaches 0 of 2. And also the limit is x approaches 0 of 1 over x squared. So when I substitute in my 0 in this first one, I get an answer of 0. Get the second one, an answer of 0. And this third one is plus 1 over 0, so that's a constant over 0. So again, I need to go ahead and put that in my calculator and graph it and see what it looks like. So graphing this, type into your calculator, we got 3x. We've got plus 2. Then we've got plus 1. And divide by x squared. So it's your graph key. And we can see from our graph that both the left and the right are heading to infinity. So notice on this graph right here, so this actually looks like this. As I approach it from my 0 from both directions, it looks like they're both just going up like this. And so that answer would be infinity. So now I just take that, add it together, and I got 0 plus 0 plus infinity. So that answer is infinity. On number 16, it says I've got f of x equals x minus 2 over x squared minus 4. And the directions say on number 16, find the value or values of x for which f of x equals x minus 2 is discontinuous. And label these discontinuities as removable or non-removable. So remember your discontinuities, they're going to happen when your denominator equals 0. So I'm going to go ahead and take my denominator. I'm going to factor this x squared minus 4. I get x plus 2x minus 2. And when I set each one of these factors equal to 0, I get negative 2. I get positive 2 as my discontinuities. So remember, removable discontinuities are when your limit equals the indeterminate form, which is 0 over 0. And then your non-removable discontinuities is when it's going to equal a constant over 0. So what I'm going to do is I'm going to substitute those two numbers in and see which one gives me the constant over 0 and see which one gives me the 0 over 0. So substituting those two numbers in, I'm going to do with my negative 2. Substituting it in. So I get negative 2 minus 2 is negative 4. Negative 2 squared minus 4 is going to be 0. So that's my negative 4 over 0. So that one would be my non-removable discontinuity. And then now substituting in my 2. So substituting the 2 into it. So I'm going to substitute my 2 into this equation right here. So I get 2 minus 2 is 0. And then I get 2 squared minus 4 is also 0. So that means my x equals 2 would be my removable discontinuity. And x equals negative 2 would be my non-removable discontinuity. On number 17, it gives us this equation. It says that f of x is going to equal 5 all over x minus 1. And then it gives us the other equation, which is g of x is going to equal x to the 4th. It says find f of g of x. So to find f of g of x, remember the definition of f of g of x is I'm going to substitute my g equation into my f equation. So I take my g equation, put in my f equation. When I do that, I get 5 over x to the 4th minus 1. So I'm going to go ahead and factor this denominator, x to the 4th minus 1, factors to x squared minus 1 times x squared plus 1. I can factor the x squared minus 1 again. The x squared minus 1 is going to factor to x plus 1, x minus 1. And my x squared plus 1 factors to x plus I and x minus I. So now, getting my answers, I've got negative 1, positive 1. This will be negative I, positive I. And remember, your i's don't become part of the graph, so you don't have to worry about those. So the only thing that we're considering is the negative 1 and positive 1. Well, you're going to notice when I do substitute that in, I've just got a constant up here. That's going to give me that constant over 0. So those two numbers right there are going to be your discontinuities. So your discontinuities are going to be at negative 1 and 1. On number 18, it says I've got f of x equals x squared if x is less than or equal to 3, and c over x if x is greater than 3. And the directions say determine the value of c so that f of x is continuous on the entire real line. So notice, to make this continuous, that means that this equation and this equation have to equal each other. So that's my first step. I set my x squared equal to my c over x. Now notice, to find my constant c, to find out what the value of c would be, here's my x values right here, 3 and 3. So I'm just going to go ahead and substitute those into my equation. So substituting in my 3 in place of my x, I get 3 squared. And placing there, I get all over c over 3. Now that I've substituted those in, I'm just going to go ahead and solve it. Solving for c. So solving for c, I'm going to go ahead and take 3 squared as 9 over c3 times both sides by 3. And I get 27, and it's equal to my c value. On number 19, they give us this equation. It says find all the vertical asymptotes of f of x if f of x equals x squared plus 3x minus 1 all over x plus 7. So your vertical asymptotes happen when you get a constant over 0. So we're going to go ahead and see our possible vertical asymptote would be when I set x plus 7 equal to 0 and solve it. So x plus 7 equals 0, so x is going to equal negative 7. So there's a possible vertical asymptote. So I need to substitute it in and see if it actually is an asymptote. So substituting in negative 7 in my equation, get negative 7 squared plus 3 times negative 7 minus 1. I'm going to do that. I'm going to get 49 minus 21 minus 1. And when I do that, I get 27. And negative 7 plus 7 is 0. So I get that's constant over 0. So that means that it reaffirms that x equals negative 7 would be a vertical asymptote. Okay, number 20 says I got f of x is going to equal, and I have 2x minus 2 over x minus 1 times x squared plus x minus 1. The directions on number 20 says find all vertical asymptotes of f of x if f of x is equal to that equation. So notice one of my possible vertical asymptotes is right here at x minus 1, so that answer is 1. But when I substitute the 1 into my equation, I'm going to get 0 over 0. So that means that x equals 1 is not a vertical asymptote. So then I look at this other equation, x squared plus x minus 1. It's not factorable. So I can't factor. There's no fraction of 1 that add up to be 1. So I got to use my quadratic formula. So don't forget your quadratic formula. We got negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to substitute in those numbers and solve it. So when I substitute in those numbers, in place of b, I get my negative 1. And now I've got 1 squared minus 4 times 1, which is a, times negative 1, which is c. And that's all over 2 times a, and a is 1. So simplifying that down, 1 squared is 1 plus 4. So 1 plus 4 is going to give me my 5. 2 times 1 is 2, so I've got negative 1 plus or minus the square root of 5 all over 2. And that right there, negative 1 plus minus square root of 5 all over 2, I separate that out. I get negative 1 plus the square root of 5 all over 2, and negative 1 minus the square root of 5 all over 2. So after using my quadratic formula, that's what I get for my answer. So now notice this right here, when I actually factor it, you can see that that is the x minus 1 is what crossed out. So I'm just left with that constant. So I don't have to check my other two answers because there is just only a constant in my numerator. And that is why I can just go ahead and write down my answer of negative 1 plus the square root of 5 over 2 and negative 1 minus the square root of 5 all over 2.